This question comes from Kwame, who asks, if the moon suddenly exploded, what would happen to Earth? The first thing to establish is what it would actually take to explode the moon. According to calculations of the moon's gravitational binding energy, the amount of energy required to blast it apart into pieces that don't simply fall back together, you would need roughly 1.2 times 10 to the power of 29 joules. That's comparable to the total energy output of the Sun over 6 minutes, or the simultaneous detonation of approximately 600 billion Tsar bombas, the largest nuclear weapon ever tested. This isn't a number that exists in any conceivable human arsenal, or in any natural process short of a collision with another planetary body. So when we say the moon suddenly exploded, we're granting ourselves something physically impossible just to ask what comes next. The answer depends almost entirely on how thoroughly it exploded. In a weak explosion, one that broke the moon into several large chunks rather than pulverizing it, gravity would almost immediately begin reassembling the pieces. The moon's mass would still be there, orbiting in roughly the same region of space, and given enough time, potentially millions of years, it would coalesce back into a lunar body. The tidal effects on Earth during this period would be chaotic and irregular, but the long-term outcome might look surprisingly similar to what we have now. This scenario is actually not entirely theoretical. Saturn's rings are thought by many planetary scientists to be the debris of a former moon that was destroyed either by impact or by crossing within the Roche limit, the orbital distance at which tidal forces overwhelm the gravity holding a body together. Earth's Roche limit is about 18,000 kilometers. The moon is currently 384,000 kilometers away, so it's in no such danger. But if it were destroyed in place, the question of whether the debris coalesced again or spread into rings would depend on the energy and distribution of the explosion. In a genuinely catastrophic explosion, one energetic enough to scatter the moon's material widely, some fraction of the debris would head toward Earth. The pieces closest to us would arrive within days. The moon is 2,159 miles in diameter and contains about 1.2% of Earth's mass, which is an enormous amount of rock. Even a small percentage of that mass directed at Earth would be vastly more devastating than any asteroid impact in Earth's history. The Chicxulub asteroid that killed the non-avian dinosaurs was roughly 10 to 15 kilometers wide. A lunar fragment, even 100 kilometers across, would deliver energy hundreds of thousands of times greater. A bombardment of such fragments across weeks and months would reheat Earth's surface, collapse the food chain, and almost certainly extinguish most complex life. The planet itself would survive. Rock doesn't evaporate, but anything living on it would not. That's the immediate picture. But even if the explosion somehow scattered everything away from Earth, an enormous caveat. Since Earth's gravity well would pull a substantial share of debris directly toward it, the long-term consequences would be profound. Tides would collapse to about 1/4 of their current strength. The sun does exert gravitational pull on the oceans, but it accounts for only about 40% of current tidal forces, the twice-daily rhythm that intertidal ecosystems have built their entire biology around. The timing of spawning, feeding, emergence would be weakened and altered simultaneously with a sky full of falling rock. Coral reefs would not survive the combination. Most intertidal life would not either. The ocean current systems, partly driven by tidal mixing, would slow and reorganize. The axial tilt problem would be slower to arrive, but harder to solve. Work published in Nature in 1993 by Jacques Lascar and colleagues showed that the moon's gravitational torque on Earth's equatorial bulge is what keeps our axial tilt confined to a range of roughly 22 to 24.5 degrees. Without the moon, the influence of the other planets, particularly Jupiter, could drive the tilt to anywhere from nearly zero to as high as 85 degrees over millions of years. Mars, which has only tiny moons, wobbles between roughly 0 and 60 degrees, and the evidence is that this has periodically covered its poles in ice and allowed its equatorial regions to thaw. An Earth with a chaotically wandering tilt would cycle through ice ages and heat spells on a geological timescale completely different from anything the current biosphere has adapted to. And then there is the night sky. Humans have organized their calendars, their mythologies, their agricultural cycles, their navigation, and their poetry around the moon's 29.5-day cycle for as long as our species has existed. Every lunar calendar Islamic, Hebrew, Hindu. Chinese would become obsolete simultaneously with the thing it was built around. The word month derives from moon. The word menstruation derives from the Latin for monthly. The moon is baked so deeply into human timekeeping and culture that its absence would leave a gap impossible to fully catalogue. There is one small consolation in the wreckage. The drag the moon exerts on Earth's oceans is gradually slowing our rotation, currently adding about 2 milliseconds to the day every century. Without it, days would stop getting longer. We would, eventually, stop needing leap seconds. Given everything else, this seems like a poor trade.